connect it and see whether we are. Probably we need to. No, not the computer. Could you get connected to live stream? Oh, okay. Good afternoon, everybody. Welcome to second routing working group meeting this week. We've got 11 presentations, so please be on time when presenting. And we'll start with Bruno.
Okay. Good morning. No, good afternoon. So I'm Bruno from Orange. I'm Stefan. We are going to talk about SPF delay. Next one, please. So two slides, two drafts, sorry. One is about the problem statement. So the draft defines the problem statement, and then it analyzes how mixing different implementations creates longer microgroups on more microgroups. And then it calls for a standardized behavior for some components of the SPF. And mostly, he calls for a standardized SPF backup algorithm, because we've seen in Toronto that it is the most straightforward change, and it is the biggest component to microgroups. It could be 1 or 2 seconds of microgroups, additional microgroups, just for this delay. And it had microgroups every time the backup algorithm is used, which is anytime the failure is bigger than a link failure. So if you have a node failure or an SRG failure, you run into a backup algorithm and you have microgroups. That's it. Now let's move to the second draft, which defines the algorithm. It focuses on standardizing the backup delay. So first step is to discuss the requirements. What do we want to achieve? What do we want to do? What properties we want? And then propose the algorithm. Let's start with the requirement. First requirement, we want to be very fast for simple failure, for link failure. Because this is the majority of the failure, link failure. And because with a single LSPDU, a single IGP message, you know about the failure and you can really adapt. So for that one, we want to be very fast. For the second type, we want to be fast in general. So because we want fast conversions. For nominal cases. On last case, if the IGP becomes unstable, we want to be slow to make sure that the network keeps calm. and especially because there are many dependencies on IGP computation. We have BGP dependency, LDP, RSPT, fast reroute, and many more. And also, we already had computed many SPF, and apparently it doesn't solve the problem, so no need to be very fast. So that was the easy requirements. Now a bigger one, a more harder. In general, we want to have the same delay on all the nodes in the same network. So it looks easy, but the issue is that different nodes will receive the LSP message or LSA message at a different point in time. So even with the base case, which is you have a mono-vendor implementation, all the same code, you can have node A, which believes it needs to do 2 SPF, and node B believes it needs to run 3 SPF. And this is because it has received the third IGP events just after its second SPF, so it has to do a new one. And the issue for SPF delay is that if you choose to increase your delay each time you run an SPF, you will have different node using different delay. So it's not so easy. So that was the requirements. Let's move on to the proposed algorithm. Let's begin with a definition. We will call IGP event a change of the link state database which required a new computation of the read. So whatever the following change, it could be a topology change, a prefix change, metric change. And also we don't do any distinction between the type of computation which is run. So you can do a full SPF, an incremental SPF, or a PRC. It doesn't matter. It's a local consideration, which is good because it gives freedom to each implementation to do the type of computations they want according to their own choice. So for the delay, we propose to have only 3 different values. First one is the initial wait. It targets link failure. So we want it to be here very fast. It could be as low as 0 milliseconds. So anything between 0 and 50 milliseconds probably won't change much. So this is the initial value. You use it only once to target link failure. So if you keep receiving other IGP events, you're typically in a node failure or SRG failures. Because for node SRG or node failure, they translate into multiple link failures. And here we still want to be fast, because we still want to have fast conversions. But we don't need to be very fast, because if we are too fast, we just do the computation before knowing all the topology change. So here, the second delay is fast wait. The third timer value is long wait. So here we target basically the unknown, which we are not in a link failure condition. We are not in a node or SLG failure condition. So apparently it's a bigger failure. We don't know it. So we want to be safe, and we have a long value, could be 2 seconds. So three different value only. So the algorithm is quite simple. For the first event, IGP events, you wait for initial wait, which is very small. For all the subsequent IGP events, you wait for fast wait, and you do so until you overshoot your convergence delay. I mean, you believe for a single event, your network should be able to converge in, let's say, 1 or 2 seconds. And you say, for 1 or 2 seconds, I let my network react to the failure. And if it didn't work, the failure is bigger than you can expect, and you jump to the third phase, which is long wait, and you stay in long wait until the network, the IGP, is stable for all down. So Chris has told me that the name is not well chosen. Time to converge is not really the time to converge, but the time to get all the topology change in the IGP. So it does not include feed update. So here you have a summary. So from left to right, you have the time. At the top, you have the timers involved. Second line is high-size LSPs or LSA or IGP events, as we call it. On bottom, we have the SPF delay value which is used. So for the first event, we wait for initial wait, which is very low, so only once. For all the subsequent IGP events, we wait for fast wait until we reach a timer, which is time to converge from the first event. So from the first event up to time to converge, we do a fast wait. And then we switch to long wait until the IGP converges, which is until the IGP is stabilized, which is until we have no IGP events during hold down. That's all. So the algorithm is not meant to be final, it's just to initiate the discussion. But still, so far, it fulfills all the requirements that we have discussed. Next one. So next step, we have presented the postgraph in Toronto in IETF90. We had a good discussion during the meeting until the chair discussed the discussion, and also on the mailing list, and also we had off-list discussions. And now we believe we would like the chair to consider adopting the working group, the document, both documents actually as a working document. And we will then initiate discussions on the mailing list to discuss what should be the requirements for the SPF delay and the algorithm.
So Eric Osborne, level 3, real quick.
Sorry.
Am I good? This algorithm is similar, of course, to what exists today, and one of the problems with what exists today is that it doesn't differentiate between repeated failures of the same link versus failures in different places. And with a sufficiently large network with sufficiently lousy transport in some countries, you can find yourself in this penalty phase almost all the time because of flap here and a flap here and a flap here and a flap there. They have nothing to do with each other, and you're not really damping anything, but you're in this long wait just because you've got so much stuff out there. It would be nice if we had an algorithm that could handle that a little better than this does.
Yeah, it's a difficult point because for link state protocol, you should have, every node should have the same vision of the network and do the same computation at the same time.
No, I understand, but
a
PE in Sao Paulo doesn't care about a PE link in Warsaw, right?
But
there needs to be some brains there.
The computation is not very hard in terms of computation time. It's maybe 10 milliseconds. And in the end, what really matters is field update on the reaction which is done by other protocol. And maybe if you're a PE which is very far from the failure, you will not need to update really your FIB.
That would be interesting to consider things like that.
More or less address your point. Not completely, but...
Yep, something like that.
Noting that for specific events, we also use the same algorithm on the LSP origination, so that would allow you to distinguish between multiple events network-wide and multiple events in the node.
Excuse me, could you repeat, please? I missed the...
The point is to distinguish between events that affects the whole network, on which you receive, you have an algorithm that allows you to slow down on the computation, but you want to discriminate between multiple events happening from the same node, from multiple events coming from everywhere. Yes. Multiple events from the same node are handled by the same algorithm, but applied to the originator of the LSP or the LSA.
Please state your name and affiliation.
Sorry?
Your name.
Stefano. Thank you.
AC Lindum Cisco Systems. I mean, that is the reason why you would have those timers configurable. And unfortunately, I think you would have to have the time to converge and hold down timer also, configurable as well. It would, the consequence, any algorithm, the consequence is you're probably going to have to modify, if you want it to work optimally, you're probably going to have to configure it. You can't rely on the default values fitting all networks.
Absolutely, absolutely. I'm not even sure we will need to put default value in the document because it will mostly change over time and depending on the condition, backhaul or back, yeah.
Who have read the draft? Very Very good. Who thinks it's a good idea to proceed with group adoption and work on it? Great, thank you.
Not my son either.
Come on.
I know that's your son. We wasn't really fair.
So we presented this draft, in IETF 91 in Hawaii, and since then we have kind of got some feedback and interests. And okay. So once more, Pushpashi Sarkar, Juniper Networks. This is about the multi-home prefix LFA that we presented in IETF 91 Hawaii. And since then, we have a couple of updates to the draft. So we have come up with the next version of the draft. So I'll just give you an update on that. Okay. Next slide.
I see exactly the same.
Yes. It's showing two copies, one small, one big.
Yeah, strange.
It's showing two copies there, one small. Yeah, doesn't have enough bandwidth. Sets the context for the next one. Okay. Yeah. So in the 0.0 version of the draft, we have actually kind of given implementation guidelines on how to do exactly multi-home prefixes and LFA selection for them, and we have given explicit inequalities for implementers, to facilitate implementers, as well as given methods to do how to do with LFA selection for internal MHPs as well as the ones for external MHPs, because we did also see some special cases need to be handled for the OSPF scenarios. And then the use case of this is mostly to increase the coverage for FRR and also utilize it for tail-end protection. Next slide. So before I proceed to the update, actually, there's a lot of text in this slide, but the gist is for the downstream path, case, whereas the simple prefix, which is not the multi-home prefixes, single home prefixes, RFC 5286 section 1 says, basically you can actually have a separate set of inequalities, whereas when it goes to section 6.1 for multi-home prefixes, it says you should do downstream path check, but you may not. So there is some inconsistencies, and different implementation taking different directions may cause inconsistencies, and might lead to even some form of micro loops, right? So with this context, I will go to the next slide, and there is some updates that we have put in the next version. Okay. So here's some so there's been some more contributors to the in 0.1 versions, and what we have also done is we have given explicit kind of pseudo code or pseudo algorithms to show how to do link protecting LFAs for the different kind of protections with MHPs. Okay, next slide. So what we have added here is that initially we said in the last version that we proposed some inequalities, and we said any neighbor that's suffices those inequalities should be picked as a LFA. But we also figured out that if one of the alternate neighbors is also a prefix origin, meaning like an area border router, so we can directly choose that alternate neighbor as an LFA, and we can skip the inequality check. But this only applies to two types of protection, which is the link protection only, as well as the node protection. Next slide. But for the case of link protection plus downstream only LFA, we cannot take that shortcut of using just taking a router which is also a prefix origin. We need to still ensure that it suffices the downstream path inequality. Okay. Next slide. Yeah, so any questions, comments? I guess you have something to.
Yes, so we're discussing how it's going to update 5286 since you mentioned it's not conclusive. So by next IETF, we'll update you on how we're proceeding with this. Thank you.
So are we taking the BIS?
We'll discuss.
Okay, we'll discuss on the email. Yeah. Okay. Okay, thank you.
Santosh?
Hey, good afternoon, everyone. I'll be presenting this IGP bandwidth-based metric draft that is newly published. So this draft actually discusses about the problem statement, the solution for this, and also FRR related stuff. But due to time constraint, I'll be discussing only the problem statement and the solution for BBM, and FRR we can discuss over the mailing list. So given the scenario where you have multiple links towards from let's consider that our interest of router is R1 and your destination is D1. So you could see that there are multiple next stops to reach D1. You can, and if you see that if we consider that default metric is 10 on all the links, then you could reach D1 via L1, L2, and L3 as the next stop. So this is an ECMP path. Now you do have L4, L5, and L6 as this backup paths available, but we don't use it because they are all their cost is more towards the destination D1. So in case if link 1 goes down, you are left with 2 links, but still they are having the metric 10 towards the destination D1, and so you'll be forced to use those 2 links. And in case the other link also goes down, you'll be forced to use the L3 link or the L3 next stop that is shown in this diagram, forcing you to use a single link, though you have a backup links L4, L5, and L6 towards the destination D1, which could satisfy a more bandwidth, right? So if we consider all these 3 links are 100 gig bandwidth, then 100 gig, then you'll see that the backup path is providing you 300 gig, whereas the primary path is still providing 100 gig. So with this, your bandwidth critical applications can have an issues with this because you will be oversubscribing on the link that is available towards the destination. So that's the problem statement, and what would be the desired behavior? In some cases, the desired behavior would be, assume that L1, L26 are all 100 gig, and link L1 goes down, and it is okay to use L2 and L3 because my requirement is that, to satisfy 200 gig. That's what my data traffic is. So it's okay to use L1 and L2. So I want to keep the metric as 10, so that I'm still using L1 and L2 next stops. So when link L2 also goes down, then I would want to increase the metric of L3 to 50, so that I start using the backup path, which becomes the lower cost here in this case, like L4, L5, and L6 taking a metric of 10, and L3 is taking a metric of 50. So by the virtue of SPF algorithm, you'll be using the L4, L5, and L6 as the primary paths now, and your traffic will be diverted towards these next stops, towards the destination D1. So this would be the desired behavior, and how you want to solve this is something which I'm going to explain in the next slides. So to solve this problem, we have come up with a solution which actually talks about grouping these links into L3 bundles, right? So based on the L3, for example, if L1, L2, and L3 are bundled as group 1, which is going towards router R2, and L4, L5, and L6 are grouped as in a different group, which are going towards R3 and finally reaching the destination D1, right? So these are the alternative paths. So we have grouped into two groups now, and the configuration, we have kept it almost symmetric. It can be anything. We can play around it. So the configuration that is displayed here explains that you want anything above 300 gig. If the bundle group cumulative group bandwidth is anything above 300 gig, if it is anything above 200 gig, I want to keep the metric as 10. And if it falls to 200 gig, I want to still keep the metric as 10. And if it falls to 100 gig or below, I want to keep the metric as 50. And if it falls 100 gig and below, then I want to keep the metric as 1000. So the default metric acts as the lowest preferred metric. I mean, if your group bandwidth is not satisfying any of the configured metric, then it will pick the default metric, right? So how does this work? So by grouping them into L3 bundles, what you're trying to do is like you're trying to see it as a single bundled link, though they are all separate. Logically, they will look as a single bundled link. So if L1, L2, and L3 all are up, cumulative bandwidth is 300 gig, and the BBM metric is 10 because the total cumulative bandwidth is greater than 200. That is configured on the group. And if L3 goes down in case, and the group bandwidth falls to 200 gig, you still want to keep it as 10. It depends on the configuration. And if L2 and L1 goes down, both of them goes down, then your total bandwidth becomes 100 gig, and I want to increase the metric to 50. So that is the flow chart which explains how to assign a metric to each interfaces which belongs to a group, which says that you have to loop through all the interfaces for that group, check for the cumulative bandwidth against the configured bandwidth. If it is if the configured bandwidth or if the cumulative bandwidth is greater than or equal to the configured bandwidth, then assign that metric to all the interfaces on that group. So by doing this, you would get a you would be playing around with the interface metric so that you can control how you want to divert the traffic towards the destination. So that's about it, because there is another part in the draft that we have explained which talks about the FRR. Since it's going to be a bit, so it's going to take some time. So I thought we'll explain it later.
This is Ahmed Bashandi, Cisco Systems. That seems to me like internal behavior to the router.
Yep.
So I looked at the draft, it says standard track. Maybe it should be informational.
Okay.
Something basic. Okay.
Okay.
That's it.
Okay.
Thank you.
Robin from Huawei.
Okay.
Okay, Robin from Huawei. So, in my opinion, that if you think the application is bandwidth sensitive, why not use MPLS traffic engineering? Because I think the dynamic change, the metric, or this the careful design, the interface working group, maybe is algorithm specific, and also maybe a dangerous way to change the topology in the network dynamically may cause some other issues. That's my opinion.
Right. Well, you could see it as we are doing it without MPLS here, and this is one of the solutions where you could control this without having MPLS deployed.
The customer, Hans Gredler Juniper, the customer who's actually been requesting that, gets allergic reaction if he sees MPLS-related TLVs in his link state database. He's coming from Sweden.
Yeah. Yes, but in fact, sometimes even the metric is static specified instead of by the user, and not is the calculate based on the bandwidth. So sometimes the metric cannot reflect the actual bandwidth of the network. I think that if you use this one, go on to change the traffic, I think it will propose the sequential result for your maybe hurt your traffic in the IP network.
Sorry, I didn't get you.
Okay, I will
cover
this in the mailing list. Okay.
Sure.
Yeah.
Eric?
2 points real quickly. One, to Hannes' point, sometimes the way to get over allergies is
Please
a little
state your name,
tiny
Eric.
dose.
Eric?
Eric Osborne, level 3. The one way to get over allergies is a little tiny inoculatory dose of stuff, so maybe it's time, you started feeding that in. But you might want to look at a thing EIGRP has had called variance. It's had it for as long as I can remember, and it does this without the operator having to think about what cost to pre-assign. Because this works well if you want to go a little bit left and a little bit right, but I don't see it working in a mesh if I have to figure out what the metrics are going to be ahead of time. That seems really difficult for this.
Okay. Okay, I'll take a look at it.
Rüdiger Volk. Actually, I think sometimes allergy are preventing bad health events happening. I'm not completely as radical as some people up north, but kind of the idea that the metrics that are configured are kind of handcrafted, of course, is something that doesn't work in a large network, and I'm quite sure that the simulation algorithms that would be used for fitting the expected load to the various failure cases of a network would actually take care quite easily of the variations. So.
Did you have a response to him or no?
I think.
No. So, Sri Ganesh Kenny from Ericsson. So there have been lots of studies about what problems will be caused by changing bandwidth dynamically, right? I mean, you never talked about that in this presentation.
Well, we are not changing the bandwidth, right? We are just changing the metric based on the bandwidth available.
Right.
Yeah.
What I meant is changing the cost and how, if you change it too frequently, there are other problems.
Yeah, right. You're right in the sense, if the link is flapping very frequently, then we might be, diverting the traffic here on the backup and then on the primary. Is that what your question is?
Yes.
Okay, so these are the things which should be handled. We can discuss in detail about how we can handle these problems over the mailing list. But I think, this is similar to what happens today in AE as well, because if a link in the bundle flapping and it is resulting to the minimum link and the link goes down, then you would be facing the similar kind of an issue.
Right. No, my point was that this approach should recommend, or at least say that you should have something built in to prevent problems when that happens.
Yes, we would do that. After discussing over the mailing list, we will include what would be the recommended value of, whether you should be immediately including it in the group, or you want to wait for some threshold before adding it into the group.
Okay. Second question, is this only when the link goes down, or is it when the link is very congested to a point where it is...
No, it is when you have a link degrade or when link goes down. We are not talking about, if too much of traffic is sent on that particular link, you want to divert the traffic. No, we are not talking about that. It is just about the link degrade or link down cases.
Link degrade as in degrade due to what? Some physical characteristics of the link, or?
Right.
It's okay.
Optical.
Okay. Yeah. All right. Thanks.
So to your first point, right? So can it cause loops? What we are doing is actually when we derive the metric out of the bandwidth, we actually also advertise it on our the link state advertisement, and hoping the other routers will react in time. You should not see a loop. Yeah. So we are flooding that, flooding the new metric that we derive from the bandwidth, and no, it should not cause loop because they should do a. So there is a separate set of metric from the router in this diagram R1 towards R2, and there is a separate set of metric from R2 to R3. So when you're talking about the other way traffic, that still might be on that link unless R2 deploys the same feature as this on this one.
Can we please take further discussion on the list?
Sure.
With regards to comments, I agree, since there's no changes to the protocols, it's not really standard track document. I would really like to see comments from operators because it kind of seems to be solving some operational problems. So I would appreciate it. Exactly.
Okay. Thank you.
Rob?
Wow, the box isn't very clear. I'm going to talk a little bit about the this policy model. It's a Yang model that describes routing policy. I'm presenting on behalf of the OpenConfig working group. Next slide, please. So just in case you haven't heard already this week, OpenConfig is a loosely coupled set of operators who are working to define Yang models, generally based on our own configuration and operational state requirements. We're trying to include items that are available in multiple major implementations, so to come up with a vendor-neutral set of models that are widely implementable. And initially we started to focus around BGP, policy, and MPLS. Previously this draft was embedded within the BGP model, but we've split it out and brought it here as a separate item based on a few different things. We're not claiming to be feature complete. We're motivated by trying to find our own configurations and being able to apply those onto the network, not necessarily by having every knob from every single implementation. Next slide, please. So just looking at the kind of envisaged model layout that we have, and we presented a draft in NetMod earlier in the week around how this might fit together. It's kind of pretty clear for us that policy is going to be pretty fundamental. It gets applied in multiple different places. So in the hierarchy, you end up with needing it in IGPs for what's flooded between areas, what's leaked, what's injected across BGP, of course, in VRFs and in MPLS. So we're trying to take those, split this into two elements. One where we have protocols that apply policies, and then on the right-hand side, the pink bit of this diagram is essentially where we define the policies. Next slide, please. And how that ends up looking is that we have two sets of elements that come together in the model. So we have a generic kind of policy framework, which does configuration of conditions and actions, and those conditions and actions are generic across all of the protocols. So they're things like matching prefix sets, matching the neighbor for a protocol that has neighbors, and then we augment that with a set of policies that are then specific to an individual protocol. So for instance, in BGP, matching community list is an augmentation that's provided by BGP to the generic policy module. And the idea is that the condition and action framework is generic across all cases, and it's only the specifics that end up being defined separately. And we also have on the left-hand side here, we have the the BGP model itself, which provides the hooks of how you can apply the policy to a particular neighbor, to a peer group, or some such. Next slide, please. So this is utterly unreadable. That's useful. So I'm going to explain what that says on the left, and you can look at the slides online, which hopefully are a little bit more readable. Essentially, how it breaks down is you have a set of common elements that you define, so things like prefix sets or neighbor sets, and then you end up with having instances of policy that are able to reference those generic sets. And those sets can be used either as a match condition or within an action to say apply this set of communities or apply this other element that's generic across all of them. The next slide, please. Again, utterly unreadable. Perfect. So when we end up augmenting the model, how it looks when you ask it specifically to build your BGP policy is that we end up with another container underneath each of the conditions and actions that has the new actions or conditions that certain protocol adds. So and they come both in the kind of defined sets element of it, so you can define a new set that's only specific to that protocol, as well as in both the conditions and in the actions to be able to set attributes or to be able to match on particular elements. Next slide, please. We've worked through this, as I said, kind of from the perspective of taking policy from existing networks and trying to write it in this language. The condition and action framework has some features like being able to call policies, which some of the operators in the group use. And we've taken this to a number of operators and had some feedback. I mean, definitely from Cisco, Juniper, Alcatel Lucent, and another couple of vendors looking at it in terms of how implementable it is. From an operator side, there's projects, I think, both within a couple of the members of the Open Config group where we're already starting to try and use this as the policy language that will be in our network. So we're actually testing it against, can we define policies that are on the real network? The aim is that this is supportable with enough flexibility that it's widely implementable, but and that inevitably means not having all the flexibility of some of the policy languages that we have. There will be a need in some cases for vendor-specific augmentations. We're making sure that we're trying to be as extensible and sympathetic to that. The model is in the draft, but it's also we try and keep this relatively up to date. This GitHub, which is the Tom Nadu's GitHub repository. So, questions, comments, abuse, rotten fruit.
Hi, Sri Ganesh Kenny Erickson. So the introduction of this draft says that it is based on best practices without any reference to it. Is there a plan to write a draft on
best practice policy definition?
What are the use cases that led to this particular model?
I don't know that there is a plan to write a draft to say that. I would point at a number of global networks that are on the authors list or in the acknowledgements, and I would say that policy best practices is a very loosely defined best practice.
Right, but that's what this is based on.
It's based on the best practices, which are the design rules within our individual networks.
I mean, I think I actually added that language, so I'll urge you not to be too literal in interpreting it. It is, as Rob said, meant to be, it captures the operational usage of policy in the operator networks that contributed to this model and draft.
I think the way to kind of read it is we're aiming not to make sure that you can use things that are maintainable from an operator perspective, right? So you could define a policy language which has no reusable sets in it, which would be very hard to use in terms of commonality and maintain. So yeah, we maybe should tweak the wording to be a little less loaded terms, which might have IETF meanings as well.
Thank you.
Perfect.
So we're still in discussion about who is doing what. In this particular case, you could see BGP model, which definitely belongs in IDR. You could see augmentation of BGP policy, which again belongs in IDR. Abstracted policy, per my current understanding, belongs here. So this is how we are going to proceed, at least to my understanding. Ali, if you would like to say something about it.
Sorry, Rob, again. Can I think it's a bit interesting, that comment. So the policy actions in the so if we look at the file names here, so in the BGP policy.yang, they're not really adding anything. They're not, so that they're just based on attributes that are already defined. So I don't know that IDR necessarily would have a comment on them, right? Because it's almost more about how do you use those attributes in the policy than it is about what is that attribute.
Some of them are very specific to BGP and not applicable.
They are. I'm just interested as to whether the approach we take is the use of the element, or it's the it's going to become quite difficult to standardize if we end up splitting it into many pieces.
Aaliyah Atlas. So I talked with our chairs in routing about how to handle a number of the different Yang models and how to handle this going forward. You can see that there's already a large extra number of Yang models coming into RTGWG, and that's not going to scale. There are two concerns that we had, or that I had, and ways to handle it. So we look at some of the models that are coming in, like the open config MPLS consolidated model, and say, this doesn't fit neatly into IETF working groups. And you know what? That's fine, because it doesn't have to. It should be what's appropriate for actual use, not fitting the management structure in the IETF. Okay? But what we're going to do is we're going to say, this is the primary working group for it. We'll make sure it gets the cross-working group review for the other content. You may end up talking about it multiple times, but you're not going to get stuck breaking it up. That said, so that's one piece of it, is if you have models that apply to multiple spaces, that's okay. Because if that's the right perspective and the right architecture that you need, you get it. Second part, though, is as we go through this, when you look at a model, you may say, here's a common subgrouping. In that case, that common subgrouping will probably, you may pull out as a separate model, pull it out even as a separate draft, leave it in the working group which has the primary use case for it. Or if there's two places where it has really good use case, the working group chairs, who all get along really well, can negotiate and discuss and decide which working group wants to be the primary for it. For policy, BGP is the primary use for a lot of the complexity, and that's why when we talked about it, we thought that it would go better into IDR. Now, of course, it's a consensus-based organization until we say, nope, this is what's happening. So I'm very interested in hearing your opinions and discussing it. This is just our first approximation. And the other side, of course, is if it's not working, we'll fix it.
So just to clarify that, so in this model, there's BGP on the left-hand side, fine, that's in IDR right now. And then on the right-hand side, there is augmentations to policy that are specific for BGP. Now, I would say that on the right-hand side, the important thing is consistency within the policy model, right? We want to have some crazy way to set it in an IGP, and then a completely different way that's even more crazy in BGP. So it is always crazy in BGP. But also that some of those things are reusable across, say, VRF import policy. Actually, I might do nasty things like match BGP attributes in an import policy. So it isn't clear to me that it's really an actual, even though it says BGP in it, it doesn't naturally to me say that it should go into IDR. I'm fine with the BGP bits being in IDR, that's perfect. But I think having consistency across the policy language is really, really important.
Yeah, Stefan Kowski speaking. I completely agree with you, Rob. We really need this generic and consistent policy framework which is cross-protocol. Policy is not just a question about BGP. BGP is a major component, but it's not just BGP. We are also using policies for inter-IGP redistribution and sometimes complex policies also.
I totally,
and we need a consistent framework.
I totally get that. But to get consistency through the model, it really helps to have the whole piece owned by a working group, but also then cross-working group presented, discussed in other places. The other option is that we take things like this, disassociate them from some of the primary uses, pull them into RTGWG, which will then explode. So then we'll have to do a routing area Yang working group where we will then proceed to have only people who care about Yang showing up, and therefore we won't have the routing expertise. So that will then shrink down into nothing and disappear in a small burst of boof. So basically, we're trying to figure out how to manage it, and the options are over-specialize onto Yang and have it go away, or try and spread out the load and keep the primary user working group or as negotiated. If it's not working or if it looks like it ends up breaking it up more, I'm happy to do that. We can be completely flexible about how this stuff is managed, but I don't want to put it into something where I can already see a failure mode. Does that make sense?
Can we go back to the last slide, Jeff?
Sure.
Yeah, you can stand there. You can stand over there.
Summoned back like a naughty schoolboy.
I like the architecture you have. In my humble opinion, and this is chair hat off, I like the architecture you have there. I think it makes sense to have the generic policy with the VGP policy underneath. In my chair hat on, I don't care where you do it, as long as it is, because we're working on it. End of statement. We'll figure it out. But I really like, in my personal engineering hat, after having struggled with the lots of pieces, your stuff makes a lot of sense.
So I don't think I was saying that we shouldn't make sure that that part's shared with IDR, because obviously there's going to be some interest there. Is this the right way to encode this particular thing that we want to match? Is this a kind of match a logical thing? It's just, I just want to keep I want to be able to, I like the fact that I can already write policy for this framework already, and losing that will be really, really bad.
AC Lindum, Cisco Systems. Speaking as a reviewer and not a working group chair, I think it would be a mistake to not keep it all together in a single model and draft, rather than, and I see the attachment, the application of the policy in the protocol modules, but I don't think you want pieces here, pieces there. I mean, you're going to undoubtedly have that for vendor-specific modifications, but I don't think we want to have multiple drafts. That's my opinion.
We may quickly run out of motivation to write lots of drafts as well, I think. Writing models is one thing, but many, many drafts that describe will be an interesting motivational thing.
Yes.
You're next. See.
So I'll just set we're bringing this up, I'll just set the stage for this. We have been working on the IGP design teams. There's a number of people in the room that are working on it. Stefan Lidakowski for one, myself, and Jeffrey Zhang for both OSPF and Ying Zhen has also been working on the OSPF one. And we decided that there was, that just like the implementations, there was a need for a common keychain model that would be reusable, and you could attach any place. Next slide. So when we first started doing this, we went through a number of iterations on this until we ended up with this model. The requirements were we wanted, again, a reusable keychain that would allow graceful rollover of keys. And we also wanted to define the containers as such that people who wanted to reuse these containers in different ways could, because they're, like for instance, the routing, a lot of vendors routing implementations allow immediate, you don't have a separate key chain. You can have the immediate specification of a key right in the protocol. I think I talked about this slide. So I'm not going to show you any models in small print that doesn't show up on the projector. I'm just going to describe it at a real high level. And luckily, this is a real simple model, so it's going to be easy to do. A keychain is similar to the keychains you all know and love. It's a global list at the top level. We put it at the top level. I know some implementations put them at the what we're calling in the routing config model at the routing instance model. So that was one reason why we defined it to be a reusable container that you could augment and put it in a different place. And within each keychain, you have keychain entries. Right now it's key, but in the next revision of the draft, I'm going to change it to keychain entries to avoid confusion between the key itself, the string, and to be consistent with the ACL model, which has the access list entry. And then you have a send accept lifetime, or only, one lifetime for the key. And then we have a choice on that because some implementations supported one lifetime that was both send and accept, and another one that supported send and accept different ones. I mean, a different lifetime for send and accept. And we made lifetime also a reusable container in case, just for modularity speaking, it's reused in our implementation. Then we have an algorithm. This is, and we have a list of all the algorithms. This is an enum. Now this is one thing we're a little bit, we didn't really know how to do. It's just like an enum. We put all the algorithms in that everybody supported. So since it's a superset, not everybody supports them all. So I guess the back end will reject it. We're open to suggestions how to handle that. And finally, the key string itself. Next slide. I think I talked about a lot of this. The keychain, which I'm going to rename to keychain entry in the next revision. This could be reused to define keychains at other scoping levels. For instance, if you wanted to use the routing config model at the routing instance level, the algorithm list can be reused for other, like for instance, for the immediate specification. If you have for the protocols, the legacy usages, which there's a lot of them that use you specify a key in an algorithm directly, and the keychain itself is also extended in draft Chan routing key table. I'm not sure if this is the right thing to do. We don't necessarily agree on this because I'm thinking a key table and a keychain are two very different ways to manage the keys, but that's something that's open to debate. At least it doesn't cloud the issue on the existing keychain. Next. Okay, this is one way. This is not the only way. This is one way you could do graceful key rollover. What you do is you send out a new key with a accept lifetime that overlaps the current accept lifetime. In other words, you're accepting packets that are authenticated or encrypted with the same key. Now, you also defined a send lifetime that's far enough in the future that you can assure that you have had time to using netconf or whatever mechanism you use to distribute your Yang model, you have distributed it to all the routers. And you're also presuming that your routers are roughly synchronized. There's no reason they have to be exactly synchronized, but roughly synchronizing using network time protocol or something else. And so what happens is, then you, at some time in the future, you want to make these long enough, the send lifetime kicks in, and all the routers start using the new send lifetime. And voila, you've done a graceful key rollover. Now, you can remove that old key right away, or you can just wait till the next time that you roll over a key. You get rid of the old one the next time you roll over. So then you'd always have two keys in your chain. You'd have in the steady state, you have the current key and the previous key, and in the rollover period, you'd have the current key and the one that you're going to move to. And next slide, final slide. What I like about the keychain is, this 2015, it's all about the application. This, and you consider the routing protocols of the applications or wherever you want. The keychain represents a reusable policy that you can attach any place in the network. You can compare that. I mean, any place in your network device configuration. You compare that to something like IPsec, where they allowed the selection of the key to permeate with the algorithm and the keys, and which was a big mistake. This is just such a much better model. Also, it can be used immediately. Once we get this in for machine-to-machine programming the keys, there's no excuse for people not to change their keys now. You can change them every 90 days, like they used to make me change my password when I worked for my former employer, or every 120 days, like my new employee. You can change them at least that often. And again, the base model, I think we put it in the right level of modularization so that the containers can be reused or augmented. And of course, I'm demanding working group adoption. I'm not requesting. Thank you.
Question, Eric Nordmark. So things are asynchronous. I don't know if in the sort of key rollover example that you also want to be able to have a status come back, so that not only can you say, oh, I handed you all of these new keys, right, these new keychains, whatever. I also want to be able to go read back all the devices or both ends, whatever, receive it before I go change the current key you're sending with. Because since things are asynchronous, the fact that you send it over whatever transport Yang uses doesn't really mean that it got programmed into whatever.
Right. We should define some operational state. We didn't, and that would be a good thing. I'll take that as a to do.
Joel Halpern. AC, you blithely discard, key tables is a different thing. It isn't a different thing. It is the agreed information model for this, and in particular, it has a structuring that was negotiated with the security folks about how you structure the relationship between keys and protocols. And it was negotiated to reflect some real-world security problems. And if you're going to just throw it out, you've got to say, we don't care about that, and acknowledge the differences.
Joel, nobody is stopping somebody from doing a key table.
We don't need two models for the same problem. If you do this model and a key tables, people will be looking, going, now which one should I implement? That's actually making things harder on folks. We need one answer, if you're not going to reflect, and if you're going to refuse to even discuss with us, reflecting the agreed structuring, which you did, then you've got to own up to it.
How many implementations who has a key table implementation on a commercial product? Please raise your hands. You do. Why don't you send me an email on that? I find that hard to believe. Anyway, this is the immediate solution. There may be a solution sometime in the far off distant future when key tables are used. I really don't think that managing your keys, if you allow the details of key selection to permeate rather than having a reusable policy that you can attach any place, I really don't think anybody wants to manage their networks that way.
David Lamparter. In the send keys, you mentioned that they can be removed by the system automatically when they are not needed anymore.
No, I didn't. You would do that using the programmatic.
Okay.
interface.
Well, okay. That's already the answer to my question.
Yes.
I wouldn't want them.
No.
Okay.
No.
Hi, this is Umma from Ericsson. I remember I was involved in the key table discussions when it's becoming RFC that time. That time also the same argument. Lot of existing implementations won't switch to the key table RFC, which came later actually after all the implementations.
And that's a damn good thing.
So in that sense, it's more practical, your approach here.
Yeah, it's much more practical.
So it's practical, but there are security concerns generally people look into the way they put it to key tables. So
why don't you send to the list what you can do with a key table that you can't do with a keychain?
No. It's like whatever you presented currently matches to the existing implementations.
Yes, it does.
Right.
I mean, 20 years of deployment experience has some precedence, I would think.
Yeah, but it's off from key tables, definitely.
Yeah.
Hi, Jason Stern from Alcatel-Lucent. My comment isn't about the specifics of the keychain technology, but more about the construction of the Yang module.
Mm-hmm.
You mentioned being able to reuse the definitions around.
Yes.
And I know it's
you
because
you could even reuse them in a key table.
because you use groupings. So the module doesn't have any actual data in it; just defines some groupings.
It does define a global list of keychains.
Oh, okay. I haven't analyzed it fully. I thought you only have groupings in there.
No,
you have actually an anchor as well.
Yes, we do have an anchor.
Because I noticed you had a leaf ref in there, which has an absolute path. So you have to. So
that was not the intention. It was the intention.
Because that leaf ref can only point to a specific use of the grouping. It can't point to the grouping in general.
Okay. I'll have to. That's going to be in the notes, right? I mean the minutes, right?
Yeah, it's just a subtlety where you used your grouping.
Yes.
Your leaf ref can work, but other places that use your grouping somewhere else, for example, they can't use that same leaf ref. So just have to be careful about people who want to point to one of these keychain policies. They can only point to the one you've defined where you actually use it in your Yang module. If other people use that grouping, they'll have to define their own leaf refs to point to those.
We are referencing it in the. You want a global list of chains, and we're also referencing it in both the ISIS and OSPF module.
Okay,
maybe
we can talk offline about
attaching. Yeah, maybe we should take this offline if we don't have it yet.
Jeff has very quickly. For your algorithms, I can probably help you with the structuring of that. The question I have for you, though, is are we aware of any implementations that may have algorithms that are only suitable for use of some of the components of the system? If so, that complicates things, and my suggestion is you should try to find out if anybody has implementations where you can't, for example, do SHA, something on one type of interface because that's hardware assisted. If that's true, that means that you need a little bit more flexibility in your model than you currently have.
We struggle with that because all the people who contributed or reviewed it do not support all the algorithms, and we do not support all the algorithms in all the places. So that's a hard problem because you're defining the policy, that you can attach someplace, and that doesn't. You want it to be reusable, but it hasn't stopped people from using them today. So.
Thank you.
So, please to discuss on the list. Please bring your comments here, especially with regards to Joel's comment and my personal comment. It does have to include operational state. It's missing.
Yeah, you can come on in. Come on up.
Hello, everybody. I'm Yan Gang from Huawei. Okay, it looks a new policy module. So actually, about this part, some architecture, the session before kitchen already have sufficient discuss. So here, I just try to introduce what we want as soon as possible. Try to close it soon. Okay, next, please. So after the last IETF meeting, we know IETF want to get a common policy architecture, but it that time we want to we take care the content of the policy, what we have, what we want. So from our view, the routing policy supports the following function. Okay, control the route advertise and control the route receiving. Even under the filter, when the different protocol import routes, filter those routes, and modify some attribute. Finally, sometimes we also can use the policy to control the FR. We call it is static FR. Next, please. So we take care how many functions should be supported in policy. Okay, like AS pass filter, like community filter, even prefix filter, and so on. All of these filter we define in same module, in same YARN file, and they are support and route policy will be based on those filter to filter to change something. Next, please. Okay, so in our policy, okay, we have basically we have node ID. We have multiple nodes, and in each node we have match clause and apply clause. And in each, right now we assign the node ID for each node. It's because its execution have the sequence. We think the ID, this list is ordered, and this sequence can be understood clearly. Okay, and the matching result of the route policy obtained based on the following aspects: matching mode of the node as a permit and deny, and matching rows. So in each rows we have permit deny, and in each node we have permit deny. Finally, these two parameters decide this policy permit or deny, and apply some to change some parameter. Okay, next, please. Okay, it is the basic mode. So right now I think no need to introduce this architecture more. Actually, we just want to get more suggestion about the content, what should be supported in policy, and how to support this, how to configure it. And about architecture, I think after the routing design team have the decision, and the other things we can just follow that. Okay, next. Thank you. So okay, we just want to get some more input, and all of if this function some parameter is lost or something. It's all.
Thank you.
Okay, no, please.
AC Lindum. So, Yang, this is a good reflection, your draft, of an existing policy model that a lot of vendors use. So it would work from that standpoint, but I think based on the penultimate, or the next two statements, I mean two presentations back, there's going to be another. It's not going to be exactly like that. So I don't know where you see it fitting in and based on our design team, how you see it fitting, how you see this legacy model fitting with the, what we're working on with routing policy as the like the OpenConfig model and the other policy models.
Actually, till now, internally we are comparing those models. Yeah, because when we design model, we also meet some question. Even now, have some limitation to represent some relationship. So we are thinking also when we discuss with some carrier how to integrate with netconf, it is a little difficult use netconf plus XML than the traditional CLI. CLI is progress oriented, but right now the XML netconf is object oriented. Some third-party NMS they have a little difficult to understand this kind of process. So internally we meet some question. Actually, we want get all of this discussed in the design team and discuss how make it easy to integrate with NMS. This way. Actually, right now, which one is better? For us, we also haven't the final decision.
Can we please take it to the list?
I think so, yeah. AC Linda again. I think yours is much easier for a product. I work on a product that implements the one that you've described, so that would be easier, but I don't think that's the final one we're going to end up with, so everybody's going to map their back-end usage to whatever the final one we end up with.
Can we keep on discuss this email list? It is sometimes it is a big problem.
So we really need the tunnel policy as well. You know, we need both of these, AC and Yanyan. We need both of these sites in both IDR and I2S. So please merge. Oh, excuse me. My apology to the whoever's taking notes. My name is Sue Hares, and I forgot last time.
So the intention is to provide common model, not
Pardon?
model per working group. Common model, so it should be reviewed in every relative group.
We need both common models, but there is really good stuff that the OpenConfig model defined, and there is really a difference between some vendor implementations. We need the Yang design team to come up with something that works for both, and I trust the people on the design team that they're going to do a great job on it, but we need it for BGP, we need it for all the IR2S filter rib stuff as well, and other things. So please, thank you for taking on this work.
Excuse me. So please, everybody review our draft. This way, about ACL queues, even this policy. Right now, too many discuss about architecture, but I think sometimes its content and the most part is used by the carrier. Also, is very very important. If we only design a so basic policy, each vendor still need expanded for some common function. It means the carrier still need to pay more effort to integrate it.
Absolutely, that's why it's important to discuss, and not only here but also in other groups who implement policies.
Rob Shakir.
that's entirely the point of the work we were doing, looking at our existing configs, is to say, we have a bunch of people who build policy. Let's look at what's common. And so we can build it, right? It kind of makes sense.
Yeah. Next presenter, please.
Hello, Robin from Huawei. This is another YARN model. That means the tunnel policy YARN model. I think this is also we can say a complete complementary of the routing policy, because we until now that because the tunnel has a different choice, so that when choose the tunnel for the route, so that we have to define some of the tunnel policy. Okay, next. Okay, so this document is just to define the YARN data model for the policy related things. The first one is the tunnel policy definition. The second one is the tunnel selector. This means how route can select, can based on the tunnel policy to determine which tunnel can be selected. Okay, next one. Okay, so this is the introduction of the tunnel policy, because at present for the VPN service or the L2 or L3 VPN, there are different types of the tunnel. The tunnel including the GRE tunnel, LDP ISP, and the static ISP and the CRSP. And also there are the unicast tunnel and also multicast tunnel. So when the service they choose the tunnel, there are different tunnels in the network. So there must be some way to determine how the different types tunnel can be selected. So this is the purpose to propose the tunnel policy. Okay, next one. Okay, so here we propose the two modes for the tunnel policy. So the first one is a random choice of the tunnels. This means that there's a difference of the there's no difference between the tunnels, but because this is the random selection of the tunnel, so there's a priority for the tunnel to be selected. So here we define this as a selection sequence. So this means that in the tunnel policy we define the priority for the different tunnels can be selected for the service. So this means one types of tunnel has a higher priority can be chosen firstly, and the tunnel with the lower priority will be chosen at the last. Okay. So the next mode is the tunnel binding. So this is directly to specify the tunnel name to determine the tunnel to be selected. So this is, we can say, is a static configuration, a specific tunnel for some route. Okay, so based on this mode, there are the more choice. The first one, the ECMP. This means that maybe multiple tunnels for the service for the load sharing. So they are the ECMP. So for the sequence mode, so we specify the number of the tunnels can be selected. So this is this means this number of the tunnel can be used for the ECMP for one service. Okay, in the tunnel binding mode, so we can specify multiple tunnel binding. So that means that more tunnels can be selected for the service for the ECMP. So this is the tunnel policy for the ECMP. So the next one is the degradation. So because some of this tunnel there has a higher priority to be selected in the tunnel binding mode, because this tunnel is to be specified. But once there are some failure on the tunnel, but if there's no alternative, so means the tunnel cannot be used for the service. So there's always a drop packet. The packets will be dropped. So here propose another choice, means the degradation. This we call it as a down switch. So this means that once in the tunnel binding mode, so the degradation from the MPRCT tunnel to the best effort tunnel can be specified. So this means we can use the TE tunnel to satisfy the constraint of the service. But once this binded tunnel is filled, so it can immediately degrade to the best effort tunnel, firstly to make the service traffic to be resumed. But after some time, when the MPRCT tunnel is restored, so the tunnel binding can be restored to the binded MPRCT tunnel from the best effort tunnel. Okay, next one. So here, this is in the peripheral, we define the tunnel policy. So here we determine the tunnel selector. This means based on the tunnel policy to select the tunnel for the routes or the service. So we have the two types of the tunnel selector. The first one is the tunnel selector for VPN instance. So I think this can be referred in the L2 VPN, L3 VPN, or EVPN YAML models. So in these models, so that it can define for specific VPN instance what tunnel policy can be used. So based on this, the tunnel selector, so the route of the VPN can select the tunnel for the route in the VPN instance. So this is not in the scope of this draft. So another that is the case is the tunnel selector for the routes, because in some cases of the VPN there's no the VPN instance. There's no VPN instance, so it cannot use the tunnel selector for VPN instance. This use case, for example, is option B inter-AS VPN, because this is in the ASBR, so that is only has a VPN v4 route, but there's no VPN instance. But even here, we want to specify to choose the appropriate tunnel to transfer the traffic from one ASBR to another ASBR. So it has to introduce the tunnel selector for VPN routes. So here, this tunnel selector for the routes is introduced to define how to select the appropriate tunnel for the VPN route. Okay, next slide. Okay, so this is a tunnel selector for the routes. So I think this tunnel selector is similar as a route policy has been defined in the previous presentation. So here it also has some of the matching rules. The matching rules has the if match clause and also the apply clause. Apply clause is just to apply the tunnel policy. Okay, so this if we based on this the match the filter, so that is apply the tunnel policy, so it can select the appropriate the route based on the tunnel policy for the filter the route. Okay, next slide. Okay, so there is the tunnel policy YAML model. So we can see here we have the tunnel policy. We have the two mode. One is the select sequence mode, and another is the binding mode. And in the binding mode, we have a down switch mode. Okay, so this is just to reflect the introduction of the tunnel policy. Okay, next slide. Okay, here is the tunnel selector for the route. This is the YAML model. So here we can see it defined. This is the selector name. So here it can match the next hop, and match the next hop, and it can apply the tunnel policy. So this means that the next hop is matched, so it can select the corresponding tunnel based on the tunnel policy. And also this need to augment the BDP YAML models. This is be used the VPN v4 family and the VPN v6 family. So in this family, it can refer to the tunnel selector name. So this for the VPN v4 route, VPN v6 route, it can based on the tunnel selector to determine the tunnel for the VPN routes. Okay, next one. Okay, so this is the first draft to be presented. So this is to solicit comments and possible the collaboration. Then we will revise the draft. Okay, that's all. Okay. Comments?
No comment. Thank you.
Okay, thanks.
Eric?
Hello, this is Eric. One more young model and 3 more to go. Okay. Okay. This is a young model for flow specification, and the goal here is try to define one standardized young data model, and which include configuration, state data, RPC, and notification for flow specification. And how are we going to do that? And first, we want to collect comments from the working group and the interested people. And second, maybe we can organize this work in the young coordinating list, and maybe if needed, inter-train meetings can be organized. And final, if necessary, we can organize one common gate to use open source to verify it. And this young data model was believed to cover the RFC 5575 and the 2 IGP protocol extension draft. Next, please. Okay, some background here. This draft was first submitted without the young keyword in the file name, and according to the suggestion from the chair, and we changed the name and resubmitted. And also, we got the help from the young section and get some suggestion from the young doctors. Thank you for their Benoit and Tom to organize the young session, and also the suggestion from the young doctors. Next, please. Okay, this is the main skeleton for the configuration part, which include which included the flow specification route, and which is organized into a list and with the name as the key, and included 2 main parts. One is filtering rules, the other is corresponding actions. Next, please. Okay, this is the more detailed view for the filtering rules. According to RFC 5575, there are 12 filtering rules altogether, and it was listed here. Maybe you guys cannot see. You can see it in the draft. Okay, next, please. Okay, this is the according action part, and yet according to 5575, there are 4 defined actions here. So we list it here. Next, please. Okay, this is stated data part for this model, and it was also organized into a list, root list, which use the index, and it's a local attribute as a key. And the state data also include some statistics here. We didn't put the detail here. Okay, this is state data, which include some protocol-specific extensions here. And we can see at least currently we have extension for 3 protocols, which is BGP, OSPF, and ISIS, and maybe more in future. We don't know. Next, please. Okay. Okay, here is actually one query or questions for the people here. And when this in this draft, I need to use the floating point type, and because it's related to traffic rate. So don't care which format it should be. For example, the IEEE floating point, but I didn't find a common type for this floating point type. And what I used here is some discussion I find in the mailing list in January this year. But the discussion ended itself without conclusion. So what comes here is currently is some kind of best current practice. So I'm not sure whether this is a correct way to go. Okay, next please. Okay, here's the next step. So we are going to collect some comments and suggestion, and we'll maybe add more part of this draft. For example, statistics, RPC notification, and we're hoping more people can join together. Thank you.
Maybe this one, Jeff.
Let me start again. Jeff has. So in BGP flow spec, the rule ordering, these being like firewall rules, is based upon the length of the route, among other things. As far as I can tell from your organization inside of the container, the list order does not have any correlation to that. I don't know if you have an answer to that now, but you should think about how the actual firewall implementation order is reflected versus list order.
The rule orders, first, this flow specification is not the message encoding for the BGP message, and the order followed here is according to the RFC. It should be from, the 12 type, right? From the 1 to 12 is according to that order. So, is that what you mean?
What I mean is that if part of the purpose of this is to provision BGP flow spec, if you're trying to impose firewall rule ordering in your model, it may not be able to be encoded on the wire.
Maybe can we talk this on the list?
Absolutely.
Okay, Robert Raszuk, one of the authors of RFC 5575. So the reason we actually use BGP for flow spec, one of the fundamental reasons was the automatic validation. And the validation happens, is described in section 6, and it happens to match actually best unicast route with the flow spec route, and only that securely apply this. If you detach flow spec from entire BGP unicast advertisements, how are you going to do the validation in this case?
I didn't think that. Can we just on the list?
Sure.
Thank you. All right, Stefan.
Yeah, Stefan Kofsi from Orange. Two comments. The first one is I have some concern about understanding the exact goal of this work. Is it just for creating static route for flow spec that could be used for injection within a BGP control plane?
Okay. The first configuration part was static configuration, but the
static for what? For your local node or for as a controller to advertise something within BGP?
I think both are okay.
Because if you are trying to build a model for PBR or something like that, it's not flow spec, it's PBR, policy-based routing, but it's not flow spec. And the other point is, so you are redefining all the filters and actions. I think this should be part of some more general groupings that could be reused, for example, ACL or PBR, but not always redefining the same things.
Sue Harris. We need filter-based policy. in the new filter-based ribs for R2S. So I encourage you, if this was part of the filter-based policy stuff with mass action, please continue on it. If you're looking for flow specs, we do have BGP models for policy that are not quite complete. We're just trying to finish the base models. So I anticipate we will actually probably have that someplace. It's just it'll be after the BGP model. For R2S, speaking as R2S co-chair, for IDR speaking as IDR co-chair, please make sure to continue to plug in at the right place. Thank you.
Okay. To initiate more discussion on the list, and I would suggest to go one more time through flow spec RFC to read why and how they did it.
Okay, thanks.
Okay.
This is Xufeng Liu from Ericsson. We're still with the Yang. This is a model about VRRP. Authors also include AC from Cisco and Mingguo from Huawei. So next slide, please. And VRRP is a little simple, useful protocol which provide higher availability for the IP addresses. So this less controversial model will provide a way to configure the VRRP protocol, and also you can get the operational status and get the statistics, and the model also defines action, which is ENRPC and notifications. Next slide, please. So since we are talking about IP addresses, so the model has a relationship with other existing models, including interface model and IETF IP model. So here we have this inheritance relationship. So the interface model will be our base model, and the VRRP model will be derived from those two models. So going further into the inheritance relationship, we can see that on the very left side, we have interface model, and at the very right side, we have our VRRP. So the interface model provides two branches, the configuration branch and the state branch. So on the top we have the VRRP configuration, and at the bottom we have a state branch. In the middle, the IETF IP model augments the interface and provides either V4 or V6 addresses. So which is exactly what we need for VRRP, so that we'll have separate the V4 and V6 VRRP instances. Next slide, please. So here, on each interface, in this case will be the IPv4, then we can define a list of VRRP instances. That little star after the instance means that we can create multiple instances on it. The key for that is the virtual router ID, so that on one interface we can define multiple instances. And on the separate VRP router, we can configure to the pretty much same thing. If you use the same VRID, then the two VRP router will will build a virtual router. So this way we can build redundancy on that. At the right, the bottom part, then we have a list of IPv4 addresses, which is all the addresses we are trying to protect. Next slide. This is pretty much the same as previous slide, just for IPv6. Next one. And then here, this is a branch for the state. So the state branch provides all the information for the runtime status, tells you what state this virtual router instances are currently behave. And you can check its backup, its master, or does this instance is the owner of the address or not. Next slide, please. And still with the state branch, we also cover the statistics. So that gave us all the information about the statistics information. Next one. Yeah, same thing for the IPv6. Next one. We also have a global statistics, and that doesn't belong to any particular interfaces, so this is global. Next one. Here we have the action, so that we can apply to the particular instance. Next slide, please. And also we cover the notification. So for any state change event or error instance, where you can get notification. Okay, next slide, please. So pretty much that's the model. It's simple, and but it's complete. Covers all aspects, and all the dependency models are already published at RFC, so we don't have some uncertainty over there. So of course we welcome comments and hope for working group adoption. Thank you.
How many people have read the document?
Just a couple of quick questions. Anis Sheikh from Google. On the IPv6 VRP configuration, you just have the virtual addresses, but you also need a link local address to be specified there, right, for v6? Is that included in the model? I may have missed it.
All the addresses specified in the IP model, not in this model.
No, but for the virtual address for the VRP group, you need to specify
which one we are covering. That's on the list. Yeah, we have that.
Okay, maybe I'll ask you the question on the mailing list. The
Yeah.
other question was, I didn't see in the model that you showed interface tracking. Is that something you plan to include, or is it not in scope for this model?
We only try to cover all the standard features in the RFCs. So any additional vendor-specific things, we have augmentation.
Yeah, I mean, the configuration, of course, may be vendor-specific, but when trying to build a VRP model from an operational standpoint, it turns out that that is actually a useful feature to have in there, and it's used in common operations. So just some feedback.
Okay. If we think everyone won't have this, we can cover that. Let's see.
Any implementation I'm familiar with has implemented tracking, so it's worth considering.
Hi, this is Rashad from Cisco.
Hi.
I have a question regarding your clear statistics.
Okay.
I think I read somewhere that that was frowned upon, that you don't want to have a controller. I think somebody maybe in the room who made that comment on one of the lists. Because if you're clearing your stats and somebody's polling them, you won't get the right value.
That was the conclusion.
I don't know that was the conclusion, but that was something which was brought up.
Yeah,
so that's
I
why I'm
also
bringing
saw
it up
some
again.
discussion, but I
Please bring it back to the list so we come to the conclusion how to deal with it.
It's a generic issues. What do we do with the statics, right? So currently, yeah, this is all the other models doing this way. So, yeah, we'll see.
So feels like it requires more discussion on the list, and we'll look
Sure.
into adoption. Lade? Thank you.
And actually, so we're running about quite a bit late. So if we could do 10 minutes and 10 minutes for the next one, we'll only be 10 minutes over. Thanks.
Less than 10 minutes, hopefully, but anyway, hi, I'm Láďa Lhutka, and I'm going to talk about the core routing data model that actually belongs to the NetMod working group and has been discussed on Tuesday at some length. And so maybe, no, that's not the right answer.
Yeah, they're out of order in the materials. So.
This is the one you said.
Okay, so that was my mistake. Anyway, move forward. Still one more, and one more. Yeah. So this was maybe the most important issue that was resolved during that session, and it's about the overall organization of the data tree. So there are two basic options that are being used by different vendors in their CLIs. One is so-called routing instance centric, where you have a routing instance at the top, a list of routing instances, and then inside it you define parameters of different routing protocol instances. And the other option is to sort of turn it around, start from the top with the routing protocol list, and then define list of routing instances for each. And there are some interesting ramifications of each design. I am not going to go into any details here, but the important point was that there was quite a strong consensus in the NetMod working group that the current approach, which means the routing instance centric design, will be the way to go forward. So I hope that we can really use it for the next work on this model, and we will try to help those implementations that use the other approach somehow to be able to map to the routing instance centric design as well. Next slide, please. Yeah, go forward still. Forward. Yeah, another important decision was to move a list of RIPs that in the current revision of the draft is like a global item, so that different routing instances can share RIPs. But as a matter of fact, there are probably no use cases for this organization, so the decision was to move the list of RIPs to routing instances, so that every list of RIPs is private to a single routing instance. Next slide, please. Just go forward. Still forward. Yeah, and still one more. Yeah, and then there was some discussion about how to assign interfaces to routing instances. Current organization is to do it under a routing instance via leafrefs, via pointing to interfaces in the coming from the IETF interface, Yang module. But again, the decision by the NetMod working group was to use a different organization, and namely configure these assignments by augmenting the interface data model and configure these assignments there. And I think these are the most important items. I will send all a recap of the discussion to the RTG Yang court mailing list, so then please comment on them there.
And I think I can stop here if AC has some more comments to that.
I think we really resolved all the issues except for this one. And I've started a thread on this one on the routing design team list. So hopefully we can at least get a recommendation from that design team. And that, that's the one with members from OpenConfig and us and some of the vendors. And I think the recommendation may be different than any of the alternatives we've discussed in the past. We'll have to see.
Okay. This document is really very late, so we would like to finish this work as soon as possible. But there was a recommendation by Benoit Claes to, in fact, finish and stabilize this work, these Yang data models, but postpone the publishing of the draft until these modules are really used by other modules like modules for routing protocols, because of course publishing it as an RFC and then realizing some problems with this module would be difficult to resolve. So I think it's a good idea. Maybe Benoit can comment on that.
So Benoit Claes, as much as I want to push Yang models RFC, these are some generic Yang models that are very foundational, and there are a lot of consumer to those. So this is one of them, and that will stay in some state. Which one, I don't know, AD review or IETF last call, whatever, for some time until we will have the consumer of that model, also in the same state. And then we're going to push all of them at the same time. It would be a mistake to rush to an RFC here.
Absolutely, thank you. So,
AC Wyndham, one thing we're going to have to do, though, in a different model is add those complex next taps. I know I think Stefan was interested in maybe working on that with some other people. So we'll augment this model with another draft with all the variations of next tops that we're going to need.
Right. We try to make sure that these augments are really possible, so we will be happy to cooperate on the development of these more complicated things.
Thank you, Lal.
Thank you.
It's really good to see also during NetMod meeting that finally reach agreement on all major components, and we can start working constructively on finalizing. Rob? So it's a short presentation of this draft previously done in TS and MPLS. So we are trying to do cross-group reviews of it because of rather deep content. Just go ahead.
Hi, my name is Ina Mini from Google. I'm going to talk about... My name is Ina Mine from Google. I'm going to talk about an MPLS Yang data model that was produced by the OpenConfig working group. So I think you're already quite familiar with what the OpenConfig working group is and what it does. Two things to keep in mind is the goal of the group, and that is to enable programmable network infrastructure, and the composition of the group, which is mostly network operators. Next. When you think of what the goal is and who the participants are, there are a set of key ideas that go across all the different Yang models produced by this group. First is the fact that model-driven configuration is a good thing because it enables us to create programmability in the network, to deploy programmable stuff in the network. We want to have vendor-neutral models, so rather than focusing on a particular vendor implementation, we want to focus on the functionality and then see how that pans out independently of how vendor X or vendor Y decides to build their configuration. The focus is on use cases, and the models are really shaped by the use cases that are encountered by the operators in this group. The models are deliberately not exhaustive in their coverage, but they should be extensible. And then finally, telemetry has to be there from day one, because without telemetry, any such model is not very useful. So regarding the MPLS model, the model covers both the label switch path configuration and the protocol configuration, the configuration of the protocols that actually are used for setting these up. The LSP configuration is driven by actually the type of the LSP rather than the signaling protocol. That's a very similar approach to the approach that was taken by the group that produced the RSVP-TE and the TE models in TEs. In our model, we have three types of LSPs: traffic engineering capable, non-traffic engineering capable, and static. They have slightly different names in the model. We're still working through naming that will be kind of unambiguous. And the signaling protocols can be RSVP-TE, SR, LDP. The model lays out a generic framework for the LSPs by their type, and protocol-specific configuration has its place in this generic framework. So what does it look like visually? We have at one layer the LSP types, and then at a layer below the signaling protocols used. Next, please. So why a data model at all? Well, we all know why a data model, because we want to have intent-driven configuration and operation. And if you think about that, if that is the goal, then what this means is that you want to focus the model around the core function that is provided. And that core function is the label switch paths themselves. It's not the protocols, the mechanics that are used in order to achieve this. So the focus is on the items that are most often subject to change, and these are the LSPs. I don't think any of us is changing their RSVP timer configuration very often. Anybody who has an RSVP network is going to change their LSPs on a regular basis. The idea is to leverage commonalities based on the LSP type, and we'll see this in a second. So at the high level, the model has three main sections. It's a global section specific to the forwarding plane, and we are focusing only on the MPLS forwarding plane. There is a signaling protocol specific section, and then tunnel specific section. And in the tunnel specific section, there are three sections again for traffic engineering capable, non-traffic engineering capable, and static LSPs. The traffic engineering capable are listed in the model as constrained path, and that does not necessarily mean that this is necessarily a path that has constraints of it. It is a path that was signaled in a way that it could potentially have constraints. So an RSVP LSP that is computed with just SPF, not CSPF, will fall in the same category. Question now?
Robin from Huawei. Why do you think the static RSP does not belong to either the traffic capable or the non-traffic engineering? Because in my opinion, static RSP also belong to both the TE capable and also non-TE capable.
It's because you cannot define attributes like constraints on a static path.
So if you do like this one, this is also
So
the protocol
specific.
specific.
A static path in this model is something that you define hop by hop. You're defining each hop in the path. That's what is a static path.
Even hop by hop is the end-to-end. LDP is also hop by hop.
No, LDP. Okay, we can argue about that in the break. So here what static means is the type of LSP where you're defining at each hop what is the label action. So.
Okay.
So let's take a look at let's take a look at traffic engineering capable LSPs. So these are named constraint paths in the model. They're always associated with a path computation method, whether this is CSPF, or maybe it is something else, and with path attributes applicable to TLSPs, such as constraints that are applicable to. The path setup contains protocol-specific information on how this is signaled. And for RSVP specifically, what this means is that setup and hold priority, for example, are going to be attributes that fall under the path setup specific section. Next, please. So, in summary, what we have is a structure for protocol configuration that's separate from tunnel configuration. And we have seen this similar approach that was taken in other Yang models as well. It is also not very foreign to how many protocols are configured today. We have a first version of the model, and for the next version, we're going to make quite a bit of changes to include the operational state, which is currently not included, and we'll continue fleshing out the model, in particular the LDP and DSR section. The model is already published in the Yang Models repository. There will be a new version in the coming weeks, and we will seek out the vendor feedback on implementation feasibility. We have also met with authors of DRAFSADT's RSVP and TE models here at the IETF, and we decided to continue conversations to align both the structure and the content of the models across the drafts.
Hannes Gredler, Juniper. Was there a reason why BGP-LU was not on the list of protocols?
Yes, because it's the first version.
Okay, all right. So not intentional.
Actually, if you read the small print in the draft, we do say, and BGP-LU will be covered.
Okay, I have one more draft. Robin from Huawei. How do you define that the MPLS TP in which of your category of your RSP? Traffic
we have
engineer?
not included MPLS TP here.
Pardon?
It's
No?
currently not covered here.
But you have to encounter this
no,
issue.
we don't. So you see, what happens is we're looking at this. We're not trying to come up with something exhaustive. We're trying to cover the use cases that we had most focus on, and MPLS TP was not one of them.
Okay.
Yeah, Eric Osborne, Level 3. Just to reinforce what Ina said, part of where this came from is a set of people that are working on it, and no one's ever asked us to do it within that group. So this is why we let things evolve in parallel. See who needs it, see who doesn't.
Sri Ganesh Kenny Erickson. Just a quick comment to the comment about traffic engineering versus static. I think we can use RFC 3031 terminology and say it is explicitly routed LSP.
That's a good suggestion.
Thank you, Ina. Thank you, everybody, for staying with us so late, and see you in Prague.
So basically, no.